Okay, in this video we're going to be looking at projectile motion, which just means problems that involve an object being thrown or launched into the air. So if you take a look at your notes, it says a baseball is popped straight up by a batter and the height of the ball above the ground is given by this function here. Now this particular function is just a specific example of a more general type of equation which is known as the projectile motion function. And the projectile motion function, its general form is this: y equals a times t squared plus v sub 0 times t plus s sub 0. Now the a in this equation represents 1/2 of something called the gravitational constant. The gravitational constant is just a number that indicates the acceleration or deceleration of a body due to the force of gravity. And the value for A, at least on Earth, is it's either negative 4.9 if we're measuring in terms of meters, that is if we're using meters, or A is equal to negative 16 if we're using feet. Those are the two most commonly used values for A. So you can see in this particular instance with the baseball, we're doing our measurements in terms of feet. V sub 0, this right here, represents the initial upward velocity of the object. And S sub 0, this term right here, represents the initial height of the object off the ground. So let's take a look at this example with the baseball. It says, using this function, which models the height of the baseball, along with your graphing calculator, answer the following questions. What is the initial velocity of the baseball? Well, remember that the form of our equation here is the projectile motion equation is this. And this value right here, v sub 0, that represents the initial upward velocity of the baseball. So the initial upward velocity of our baseball is v sub 0, which is 64. And let's go ahead and put some units on here. Remember, we're talking about our height is in terms of feet and time is in terms of seconds. So our initial velocity is 64 feet per second. Also, let's notice that our initial velocity is positive. That's because when we first hit the baseball, it's moving up in the air, so our velocity is positive. If the velocity was negative, that would indicate it's falling down towards the ground. So part B, how high is the bat off of the ground when the batter makes contact with the ball? Well, the height off the ground, that's when the batter makes contact with the ball, that's also the initial height of the ball when it first gets launched into the air. And that initial height is given by this value right here. That's our S sub 0 value. So S sub 0 is just 3, and again our units here are in feet. So the baseball is 3 feet off the ground when the batter makes contact with the ball. Part C, how high does the ball travel in the air? In other words, what is the maximum height of the baseball? Well, since our graph here shows us the height of the baseball as a function of time, I can see that the baseball reaches its maximum height right here. And if I enter this function into my graphing calculator, I can use my maximum function on my calc screen. I give it a left bound, I give it a right bound, and I give it a guess point. And it's going to tell me that point right there on my graph. And it tells me that that point is the point 267. And so I know that my maximum height is 67 feet. And I know that I reached that height when t equals 2 seconds. So 2 seconds after the ball leaves the bat, it has reached its maximum height and then begins heading back down towards the ground. Part D, how long does it take the ball to hit the ground? Well, that's going to be this amount of time right here. Where the ball hits the ground is where the height of the ball becomes 0. That's also the 0 of my function, so I can use the 0 function on my calculator to figure out what is this 0 value. And I give it again, I give it a left bound, I give it a right bound, and I give it a guess, and it will tell me that the value for time when the height of the baseball is 0 is approximately 4.046 seconds. All right, example number 2. A golf ball is hit off of the ground with an initial upward velocity of 30 meters per second. A says, write an equation to model the height of the golf ball over time. Well, once again, this is a projectile motion problem, so I'm going to be using this form of the equation. And once I know the values of A and V sub 0 and S sub 0, then I've got my equation. So let's see, A, I remember that's my gravitational constant. Now in this case, I'm talking about my measurements are in meters. So for this case, my value of A is going to be negative 4.9. That's the value, that constant that we use when we are measuring things in meters. So I know my value for A. V sub 0 is my initial upward velocity, and I'm told that the initial upward velocity of my golf ball is 30 meters per second, so V sub 0 is 30. S sub 0, I'm told the golf ball is hit off the ground, so my initial height of the object off the ground is going to be 0. Well, I just take all these values and I plug them into my equation, and I get y equals negative 4.9 t squared plus V sub 0 is 30 times t, and S sub 0 is equal to 0, so I could, if you want, you can write plus 0. I'm just going to leave that off. And there is my equation for the height of the golf ball as a function of time. B, sketch a graph of this quadratic function. Well, now that I've got that equation, I can just plug that into my graphing calculator, and if I do that, I'm going to get a graph that looks something like this, very similar to the graph that I had before. And actually, let me go ahead and fill in, this is t in seconds, and this is, let's say y, and this is in meters. Okay, so there's my graph. What is the maximum height reached by the golf ball, and when does it reach that height? Well, my maximum height is going to be right here. I'm going to use my graphing calculator to find out what's this maximum value here, and if I go to use the maximum function on my calculator, I discover that this point is x value of approximately 3.06 and a y value of approximately 45.92. And that tells me that the maximum height, we call that h max, the maximum height of my golf ball is this y value, 45.92 meters. And it reaches that height at time t equals 3.06 seconds. Part D, when is the golf ball 5 meters off of the ground? Well, the golf ball is going to be 5 meters off the ground. So let's see, if right here it's about 45 meters. 5 meters off the ground is about right here. I want to know when is the height of the golf ball equal to 5 meters. Well, it looks like the height of the golf ball is going to be at 5 meters. It looks like that's going to happen at 2 points. It's going to be happening right here and also right here. In other words, it's going to be at 5 meters off the ground when the ball's going up, and then it's going to be at 5 meters off the ground again when the ball is coming down. So I'm going to have 2 answers for this question. And for both of them, probably the easiest thing to do is if I will enter into my graphing calculator, I'll enter along with y1, which is this equation. If I enter y2 equals 5, that'll give me a straight line across here, and I can just find these two intersection points, and I've discovered that the value for t for this intersection point, y2 equals 5, so let's see. Y is going to be equal to 5 at t equals 0.171 seconds, and at t equals 5.95 seconds. Finally, I'm asked, when does the golf ball hit the ground? And the golf ball is going to hit the ground at this point right here, and that I can see is one of the zeros of my function, so I can use the zero function on my calculator to find out what is this value for t, and that tells me that that value for t, when the ball hits the ground, is 6.12 seconds, or just a little bit of time after it passes the 5-meter mark on its way down.